Okay, the Venn diagram shows a number of pensioners who has a daily pastime. They either read, they watch TV, or they go for a walk. If a pensioner is selected at random, find the probability that the pensioner goes for a walk. Now, the first thing I'm going to have to do, if you guys will get out your calculators, is I need to find out how many people there are. So we need to add how many people there are in this. We have to add all these numbers together. We need to find out how many pensioners are we actually talking about here. Okay, add all those numbers together. Once a couple of us agree, we can say that's the number. What you get, Heyman? Heyman says 1,000. Does anybody confirm Heyman's 1,000?
Yes.
Okay. Okay. 1,000. Now, first thing, how many of them go on a walk? Now, 25 is walk only. 275 is walk and TV. 50 is walk, read and TV. 200 is walk and read only. Whatever you say, everybody in this circle walks. Agreed? Add them all up together. So 550 divided by 1,000. And we want to go for that then? And we get 11 over 20? Awesome. Okay. Next one. Goes for a walk and watches TV. You have to walk and you have to watch TV. You have to do both. It doesn't say or. It says and. So to me, walk and watches TV is these two sections here. So 325 out of? And what's that broken up in the fraction form? 13 over 40. Awesome. Okay. Does none of these activities? 10 out of how many? 1 over 100. No bother. Okay. Reads only. 20 over 1,000, which is? Awesome. Reads or watches TV. Reads or watches TV. So you have to be careful with this one. It means, so everybody who reads is in here. Or they can watch TV. I'm going to add all these together. Oh, sorry, my fault. Reads or watches TV. Just because they do more than one of them. Everybody in that list either reads or watches TV. Just because they do extra stuff doesn't matter. So what was I add all them together? Sorry, just the actual number before you broke it down. What? 965. It's actually just easier just to take away 35, wasn't it? 965 over 1,000, which is? Yeah. Okay. Does at least 2 of the pastimes. At least 2. So get this. You're disqualifying out. He only does 1. They only do 1. He does nothing. He only does 1. There's your list there. These are the people that do 2 and 3. So how many did you get for this? So 645 over 1,000, which is 129 over 200. Okay. Would you all agree question 4? Quite an easy question. Okay. Let's move on. 7. Calculate the value of X. People who like wine, like beer, and like both. So what we're going to do here is 135. So everything has to add up to 135. So get 135 and take away 75, take away 18, and take away 15. And what you get? 27. Just waiting for somebody to verify. 27. Okay. What can you say about the customers marked in region X? Huh? Yeah, they like wine and beer. Like they'll drink both. Okay. Now, if one customer is chosen at random, what's the probability they like neither wine nor beer? 15 over 135, which is 1 over 9. Awesome. One of the customers is chosen at random likes wine. You already know they like wine, don't you? That means you're not doing it out of 135, you're doing it out of 102. You already know they like wine, so that's only 102 people qualify for that. What's the probability they also like beer? 27 out of the 102, which is what? Awesome. The next month, the owner expects to serve 570 customers. Estimate how many of those customers he'll expect to like beer. Well, if you have 570 people, and how many people like beer? 18 plus 27. He's expecting 45 people out of every 135 people to like beer. What's 45 over 135 out of interest? Yeah, he's expecting 1 out of every 3 people to like beer. And then 570 by a third, he's expecting 190 people to drink the beer or want the beer. Everybody cool with that? Any questions? That's pretty handy. Right. 10. Now, this one's a bit more, how do we say, it's a bit less day to day. It's a bit more theory based, okay? Everybody focus, because this is the hard one, okay? Now, here's what you're going to do. You're going to set up a universal set. How'd you set up a universal set? Not a square. Nice rectangle there, okay? How many letters do you see apart from U? I see P and Q. Don't mistake U as a letter. Okay, it means what's it? Union. Okay. P here, Q here. Okay. How many people are inside? 20 people in the box. No bother. P intersection Q. X. What does this mean? Everybody inside P that's not inside Q is, so 2x, yeah? Okay. What about the next one then? Everything outside P union Q has to be 4 people. What do the hashtags mean? How many of them there in total? So if I wrote a list, I could say Anto, Ben, Carl with a C, and Daniel. Those 4 lads are outside P and Q for some reason. But I wouldn't list them all down. Because it's a hashtag, I'd say, look, it's just 4 of them. Is that okay with you guys? The hash means, the hash symbol means 4 of them, okay? Now, lads, the number of people in Q equals twice the number of people in P. So how many people are in P? 3x. See ya? P is 3x. How many people should be inside Q then? So how many people should be here? Done. Now, finally, I'm going to figure out what x is. Any idea how I can figure out what x is? Charlie? Add them all together and what should they all equal? 20 people. So what do we get here? 8x plus 4 equals 20. 8x equals 16. X equals 2. So 10 people, 2 people, and 4 people. What's the probability of Q? How many people are inside the Q? How many? 12. How many people in total? 20, which is 3/5. Okay.